Hello, my name is Sahil Mauji, and the concept that my group and I struggled most to understand is luminosity.
Angelo Lomelli. Summary. Luminosity. Noun. The intrinsic brightness of a celestial object, as distinct from its apparent brightness diminished by distance. The rate of emission of radiation, visible or otherwise. How to find luminosity. To find luminosity, first you must find the distance between you and the star you're trying to identify. This can be found through the use of the parallax equation d equals 1 over p. D is the distance between you and a star. P is the parallax angle. B is the baseline, or the distance between the point of reference and the object it orbits. Luminosity and distance. Now that we have the distance between you and a star, we can start to find the luminosity with the equation to the right. Apparent brightness and distance have an inverse squared relationship. That is to say, an object with a certain luminosity will become increasingly more and more dim the further we go. For example, a star that is 2 light years away will seem a quarter as bright as it should be. Luminosity and a star's characteristics. Now that we have an understanding on how to find luminosity, we can talk about the factors that affect it. A star's luminosity is directly related to its stellar radius and surface temperature, alongside Stefan Boltzmann's constant. Wien's law states that hotter black bodies emit photons of shorter wavelength. Stefan revised Wien's law to include the fact that not only do hotter objects emit shorter wavelengths, but they also produce brighter photons on all wavelengths. A common way scientists categorize stars is with the Hertzsprung-Russell diagram, with luminosity as the y-axis and temperature as the x-axis.
Hello, it's Sahil Mauji again. Why luminosity? We chose luminosity because of its great significance in astronomy. It's the bridge that gaps observational astronomy to the characteristics of a star. Because of its nature as the link between equation, luminosity became very difficult to understand. When it comes to the Boltzmann equation, it's very difficult to understand how someone can find luminosity with temperature and radius. We are nowhere near the star, so we can't really measure radius or temperature. We can find the temperature by comparing the color of the star to other similar stars, but those comparisons aren't always reliable due to factors such as redshifting and other objects absorbing some of the light. Importance in astronomy. Without luminosity, we would not be able to study astronomy. It is a factor that helps astronomers categorize aspects of a star when compared to the energy the star gives off. It helps us identify the relationship between surface temperature and radius of stars. It also helps us understand that a star loses brightness the further it is. Luminosity is so important that to categorize stars, astronomers decide to map their brightness when compared to their temperature. Luminosity impacts the course because without luminosity, we wouldn't be able to identify the many characteristics of stars.
Hello, my name's Ethan. Analogy of distance and luminosity. Picture 2 similar candles. Now imagine one candle a couple of feet away from you and the other candle a couple of yards away. Now imagine both candles were ignited. The candle closer to you seems brighter than the one farther away. But that's not how things are. The closer one only seems brighter to you because the distance the photons have to travel is far less, thus giving it more influence, while the photon of the farther candle are more scattered. Analogy of luminosity and size. Now picture a candle next to a bonfire and both were ignited. Both the candle and a bonfire produce light through fire, and both fires are around the same temperature, yet the bonfire is way brighter than the candle. The only difference between the two objects is the sizes. The bonfire is way bigger, which is why it is more visible when compared to the small candle. Analogy of luminosity and temperature. Finally, replace the bonfire with the road flare of the same size and shape as the candle, the only difference being that when a flare is ignited, the heat produced by the flare, 1600 Celsius, is a little less than double the heat produced by a candle, 829 Celsius. The flare would burn brighter than the small candle due to the higher temperature produced when lit.
Improvements. Luminosity was a very difficult subject to learn without really using examples. The only time we ever practiced the equation was in the homework. If we were given practice problems to test our knowledge, then over time it would become second nature. Luminosity is a very difficult subject to understand due to its very specific nature of being related to huge interstellar objects. We can't really go out and interact with stars to help yield a very specific circumstance, so the best option to help would be analogies.